Welcome to Leetcode JavaScript, a channel where we solve every single Leetcode question using JavaScript. Today we have Leetcode 49, group anagrams. This is a medium question. It's slightly tricky because the first thing that comes to your mind is probably not the right answer, but there's a few ways to solve it, and I'm going to show the most optimal one. Let's begin. Given an array of strings strs, group the anagram together. You can return the answers in any order. In an anagram, if you do not know, is a word or phrase formed by rearranging the letters of a different word or phrase, typically using the original letters exactly once. Okay, so this problem just screams that you use hash tables or some sort of hashing, because you can just count every single occurrence of a letter and then compare whether the occurrences are the same in two strings. For example, eat and tea and ate, they all have one A, one T, and one E, and that way you know to group them together. But in practice, actually doing that might be a bit harder, and I think I got a clever solution that involves using an array instead of a hash map. We still use the hash map as an outer layer, but for the actual comparisons we use an array, and I'll show you. So as I told you, we start with a hash map, so let h equal to a JavaScript object, which we can use as a hash map in this case. So we're gonna use a for each loop. So the syntax is for let s of strs. So for each string of strs is a for each loop. We'll create a temporary variable, and this is actually gonna be a new array of size 26, and it's gonna be initialized to all zeros. So 26 simply representing every single letter of the alphabet, and then we're gonna have an inner loop for let c of s, meaning for each character of the current string. For example, the first s in this example is gonna be eat. Then we're gonna iterate for each for each character. So we're gonna assign. We're going to do the following operation rather. So we are concerned with the character code of there. So we can do c.char code at 0 minus, we're going to use a.char code at 0. And this simply means each character has a code, and we're guaranteed in this case that they're all going to be English lowercase letters, and we're guaranteed that for any value, let's say v is going to have a value. I wouldn't really need to know what the value is, but if we reduce the value of a, or the character code, we guarantee this to be equal to 2, or rather 1, and a is going to be assigned to 0 and b equal to 1, and so on and so forth. And we're just actually going to be using that as indexes of our array that we initialized beforehand. So we have temp c char code at 0 minus a char code at 0. So this is just going to give us the current letter of the alphabet. We're going to increment that by 1. If you remember, we initialize everything to 0, so that's fine. That's a way to count all the things that we're doing. Now we're gonna have a check variable, let's call it check, that is gonna be temp that to the string. This is just shorthand of appending every single character so it forms a string. I'm gonna just give a small example. Let's say we have a work something like ABC, and this string is gonna be 1 1 1 and a bunch of zeros all the way up to 126 characters. I could do this with a loop. In an interview, would probably be best to use this with a loop, but just a little shorthand so you know what's going on. And finally, we check whether check is in the hash map h, and if that's the case, we're gonna push the current check. Check is going to be equal to check. And otherwise, oh well, in this case we actually need to push s. We're gonna be pushing the entire word. So to better understand this, well, first let me write the last case. So otherwise h of check it's gonna be to an array that contains only s. So how does this work? Let's assume we have eat and we have 8. For both of these cases, the array is going to be looking something like this, right? So for both of this, we're going to have, as a result, an array that looks like this, and we're going to convert it to a string. And the first time we have eat, we simply initialize check to array that contains eat. But the following time, the current word is going to be 8, but we have the same array or the same string that we're checking, so we can just add 8. And finally, we're going to have, in this case, well, eat, comma 8. And finally, we need to return something, and then this might be not super obvious, but in JavaScript, we can simply return object that values of age. So just to give an example again, let's assume we have two types of anagrams, one that looks something like this and one that looks, just to give an example, something like this. And each of these are going to be assigned to an array. And this could have any number of strings, and this one is also going to have any number of strings. And we're simply just going to return the values that correspond to every single one of those. Since we don't really care about the order, or we don't really care about how everything is returned, as long as we return everything that's required from us, we can just return all the values, and JavaScript's just gonna give it us in whatever order that we want. So we can just run this. Oh, okay. That failed 0. We just need to fail this with 0. It's just a small mistake. And there you go. This was accepted for the fixed example. Let's try submitting this and see if it is accepted for everything. And it is. Okay, so the time complexity of this is going to be initially of n when we have this outer loop for each s of strs, where n is the length of strings. But if you see, we also have an inner loop of each character of s. So that's going to be n times m, where n is the length of the strings and m is the average length of the strings, because this don't really have to be the same length. It could be any length. And thank you so much for watching. Don't forget to like and subscribe.